Lesson 15.5 is about fundamental counting principles. So our objective is just to apply fundamental counting principles, which says if one selection can be made in m ways, and for each of these a second selection can be made in n ways, the number of ways the two selections can be made is the product m times n. So that sounds a little confusing. It's really not so bad. Think of it this way, like if I said, you go to a restaurant and you're ordering a sandwich, and there's 3 different types of meat and 5 different types of bread. So the question would be like, how many different sandwiches could you make? What did I say? 3 meat, 5 bread. So that's like your M and your N. 3 selections for the meats, 5 selections for the bread. So the total number of different sandwiches we could make would be 3 times 5, or 15. So let's do some examples. Example 1, how many positive odd 2-digit numbers are less than 70? So we need to think about the number of ways each of the digits can be selected. So we're going to have the first digit, so digit 1, and the second digit, so digit 2. And then we're going to multiply those together. Remember, our m times n. So, okay, we just have to think about it. It has to be positive and odd and less than 70. Well, if it's going to be less than 70, the only numbers that could go for the first digit would be like a 6, because that would be in the 60s, or a 5 for the 50s, or a 4, or a 3, or a 2, or a 1. Now, on the other hand, the second digit has to make sure that it stays odd. So in that case, it could only be 1, 3, 5, 7, or 9. So if we count then, there's 1, 2, 3, 4, 5, 6 selections for the first digit. And then there's 1, 2, 3, 4, 5 selections for the second digit. And so if we multiply that together, there's 30 different numbers that meet that criteria. Example 2, how many 7-digit phone numbers can be created if the first digit cannot be 0 or 1? So it's a 7-digit phone number, so 1, 2, 3, 4, 5, 6, 7. We're going to figure out the number of ways each of these digits can be selected and then multiply them all together. So it said the first digit cannot be 0 or 1. Well, that means the only numbers it could be are 2, 3, 4, 5, 6, 7, 8, or 9. Remember, it's got to be just one digit. So that's 8 different possibilities. Everything else can include 0 and include 1, so that's 2 more options. So there's 10 choices here. And then each of those can be any of those 10 choices. So now multiplying all of that together, we get 8 million phone numbers. Example 3, how many license plates of 7 symbols can be made if the first digit cannot be 0 and the next 3 symbols must be letters? Okay, so first of all, there's 7 total digits, so 1, 2, 3, 4, 5, 6, 7. And I like to make little notes under each one. So it says the first digit cannot be 0, so I like to make a little note underneath that, not 0. And the next 3 symbols must be letters. So this is a letter, letter, letter. Then after that, there's no restriction, so this could just be a letter or it could be a number. We don't know. Either one. All of those are possibilities. So now we just have to think about the number of possibilities there, and then we can multiply them all together. Okay, so the first one is a digit that's not 0. So it's either 1, 2, 3, 4, 5, 6, 7, 8, or 9. So in that case, there's 9 options. Now for our letters, we just think of all the letters in the alphabet, and there's 26 letters in the alphabet, so each of these has the option of 26 letters. Then for this last one, if it can be a letter or a number, so there's 26 letters, and there's 10 single-digit numbers if we include 0 for that one. So in that case, there's 36 possibilities. Then using the fundamental counting principle, we know that we would multiply all of those together to get the total number of license plates. So let me write the answer. This is a whole lot of license plates. Example 4, how many different student government groups, being that there's 1 student per grade, can be picked from 5 seniors, 4 juniors, 8 sophomores, and 2 freshmen? So there's 5 spots. So how many different groups? 4 spots, 1 student per grade. So there's going to be a senior pick, a junior, a sophomore, and a freshman. And then we just want to think how many choices there are for each. So there's 5 seniors to choose from. There's 4 juniors to choose from, 8 sophomores, and 2 freshmen. Fundamental counting principle tells us we can just multiply those together for the total number of possibilities. There would be 320 different student government groups that could be generated. Example 5, how many different ways can you deal 5 cards? Okay, for this one we need to know a little bit about cards. So let me first go ahead and put 5 blanks here. 1, 2, 3, 4, 5. Basically, the thing that you need to know is that there's 52 cards in a standard deck. So for the first card that's dealt, there's 52 options. We have all 52 cards to choose from. But for the second card that's dealt, I already gave you one. So now there's not, as the dealer, there's not 52 in my hand to choose from anymore. There's only 51 to choose from. And so on and so forth. So if the dealer gives you 2 cards, well, the dealer has 2 less cards in their hand. So for the next choice, there's only 50 to choose from. And then 49, and then 48. So if we multiply these all together, fundamental counting principle tells us the number of ways that we can deal 5 cards. Example 6, how many license plates with 3 symbols, letters, and digits can be created with at least 1 number in each? So this sounds similar to a previous example, except for that now we have this idea of at least. So at least means there can be 1 letter, or 2 letters, or 3 letters. There's at least 1 letter. So let's start with 1 letter. So these are short license plates. There's only 3 symbols. So if there's 1 letter, that means that, let's say it goes letter, digit, digit, right? So again, it said letters and digits. So if there's 1 letter, that's 26 letters to choose from. And then the digits, which are 0 up to 9, there's 10 of those. Now there's one extra little thing we need to think about here. Here I put that it went letter, digit, digit. But what if it goes digit, letter, digit? Or digit, digit, letter? Those are different options of where the letter actually is. Is it in the first spot, the second spot, or the third spot? So what we have to do there is multiply everything by 3 to account for the fact that the letter can go in 3 different locations. So multiplying that all together, we get 7,800. So that's the number of license plates for 1 letter. But because it says at least, we also need to check 2 letters and 3 letters. So for 2 letters, we're going to have letter, letter, digit, first of all. So that would be 26 times 26 times 10. But for this one, don't forget, I could either have it go letter, letter, digit, or digit, letter, letter, or letter, digit, letter. So again, I have 3 possibilities to multiply by. So that's 2280. Finally, the last option is 3 letters. So letter, letter, letter would be the only possibility there. And that's 26 times 26 times 26. So if we do that, we're going to get 17,576. Now the total possibilities then is what we get when we add all of these up. The 7,800, 20,280, and 17,576. So our final answer is 45,656 license plates. Just put plates. Okay, that was lesson 15.5. Go ahead and see Schoology for your homework.